In this video, I am going to solve this problem. I have been given this equation. This equation represents a curve. Now, we need to find the tangent line to this curve where the curve intercepts the x-axis. And also, we need to find the equation of the line that is perpendicular to the tangent line and also goes through that point. To solve this problem, I just need to find the x-intercept first. Remember, the x-intercept of any function or any curve is where y is equal to 0. Once again, x-intercept will have y coordinate 0. Let me sketch something quickly here right on the side. So if this is your x-axis and this is your y-axis, think of this is the curve, okay? So this is the x-intercept, this point. At this point, y coordinate must be 0. So to find the x-intercept in the given equation, we set y to 0. Note that if we set y to 0, this term is going to go to 0. So this is going to become 0. Okay, because 0 times x minus 2 times x minus 3 is going to be 0. So I'm going to be left with x minus x plus 7 is equal to 0. If I solve for x, we are going to get x is equal to 7. So my x-intercept for this curve is going to be 7, 0. Now we need to find the tangent line at this point, 7, 0. Now remember, to find the tangent, we need to find the derivative. So what we are going to do, we are going to take this equation, given equation, and take derivative. We are going to have to take implicit derivative here. So I'm going to take derivative of the both sides. So the derivative of the right side is of course going to be 0, right? Now the left side, I could write it as d over dx. Now I'm going to do a little bit of simplification here. Y times, I'm going to multiply these two out. If I do that, I'm going to get x squared minus 5x plus 6. Then minus x plus 7 is equal to 0. So I'm going to use the product rule and addition rule for derivatives to simplify this. So this is going to be d over dx y times x squared minus 5x plus 6 minus derivative of x with respect to x is 1, derivative of 7 with respect to x is 0, because 7 is a constant. Now I'm going to use the product rule to take the derivative of it. So it's going to be y times the derivative of x squared minus 5x plus 6. So derivative of x squared minus 5x plus 6 is going to be 2x minus 5 times, plus x squared minus 5x plus 6 times dy over dx. I have used the product rule here. So just to remind you, product rule is d over dx uv is equal to u times derivative of v with respect to x plus v times derivative of u with respect to x. In my case, u was this y, so that's my u, and this guy was my v. So I have used that. Then minus 1 is equal to 0. Now let me go ahead and simplify it further. It's going to be y times 2x minus 5 plus x squared minus 5x plus 6 times dy over dx is equal to 1. Now I'm going to just simplify it further, and if we simplify it, we get the following. So in going from here to here, all I have done is just moved this term to the right. So that gives me 1 minus y times 2x minus 5, and then divide both sides by x squared minus 5x plus 6. So that's what I get. So dy over dx. Now that's the slope. Remember, derivative is the slope. But we need to find the slope at what point? We need to find the slope at 7, 0. That means I need to evaluate it at 7, 0. So my derivative or the slope at that point is going to be 1 minus 0. Y is 0, so it's going to be 0 times something that's going to give me 0, divided by x is 7, so it's going to be 7 square minus 5 times 7, because 5x, right? X square minus 5x plus 6. So that's going to give me 1 over 49, 7 square minus 35 plus 6. So that's going to give me the slope to be 1 over 20. So the slope at that point is 1 over 20. Now I know the slope of the tangent line and I know the point through which it goes, which is 7, 0. I can easily find the equation of the tangent line. So it's going to be y is equal to mx plus b. Or you could use y minus y1 is equal to m times x minus x1. Doesn't matter. So you could also use y minus y1 is equal to m times x minus x1. Okay, so x1, y1 is the point it goes through. This equation will be slightly easier for this problem, so I'm gonna just use that one. So y minus y1, so it's gonna be y minus y1 is 0, because this is equal to m is 1 over 20 times x minus x1, which is 7. Now if I simplify it further, I get y is equal to 1 over 20 x minus 7 over 20. And that, by the way, is the equation of the tangent line. Now we also need to find the equation of the line which is perpendicular to the tangent line and also goes through the same point, 7, 0, which, by the way, could be found very easily. Remember, if you know that two straight lines are perpendicular to each other, then their slopes have a special relationship, which is basically they are negative reciprocals of each other. So slope of the perpendicular line, so let me write down here, perpendicular line slope is going to be negative 1 over 1 divided by 20, because the slope of the tangent line was 1 over 20, which you can see here too. So it's going to be just negative 20 if you simplify it. Now once again the equation is going to be y minus y1 is equal to m times x minus x1. So it's going to be y minus 0 is equal to m, in our case now is negative 20, times x minus x1. x1 is 7. If I simplify it further, I get y is equal to negative 20x plus 140, because negative 20 times x is negative 20x, negative 20 times negative 7 is 140. So this, by the way, is my equation of the perpendicular line. So now let me summarize what I just did, and this is what I have done. I found the x-intercept by setting y to 0. Then I took the derivative of the given function, and then I found the derivative. Once I found the derivative, I evaluated it at 7, 0, which was the x-intercept, right? I mean, yes, at the x-intercept. And once I evaluated it at x-intercept, I found the slope, which is 1 over 20. That was the slope of the tangent line. Now, by using this equation of the straight line, y minus y1 is equal to m times x minus x1, and using the slope 1 over 20 and the point 7, 0, I get the equation of the tangent line. Now I find the equation of the line perpendicular to the tangent line that goes through 7, 0 is this, by this. Remember, the slopes are negative reciprocals of each other if they are perpendicular lines. So the slope of the tangent line is 1 over 20, negative reciprocal of it is just 20. So my equation of the perpendicular line is y minus 0 is equal to negative 20 times x minus 7. If I simplify it, I get this one. I hope that this discussion was helpful. Thank you very much.